Welcome back to WAPSI. Well, shall we move on to our first question? Here is our first question. The type of linkage present between the nucleotide. What would be the nucleotide's linkage here? Okay. How can you explain the nucleotide linkage? Nucleotides are joined by the phosphodiester linkage. We have studied in the biomolecules chapter. Okay. So this is an easy one. So the correct option would be option B, phosphodiester linkage. Okay. Phosphodiester linkage. Okay. And our next question is alpha D plus glucose and beta D plus glucose are what kind of? Is it an enantiomers, conformers, epimers, or anomers? Well, as we see that both these D glucose contains an anomeric carbon, you know that a carbon in which this right here is the anomeric carbon, because this carbon has a capacity to link the other side of pentose sugar to form a glycosidic linkage. So this is the anomeric carbon. So by saying that both alpha D plus glucose and beta D plus glucose are anomeric, because the first carbon in each glucose molecule is anomer. Okay, anomeric carbon. So therefore both of them are called anomers. And we'll have to move to our next question. Okay. When a tertiary alcohol A reacts with 20% of H3PO4 at 358 Kelvin, it gives a compound B, C4H8, as a major product. The IUPAC name of the compound B is, how could we identify the IUPAC naming of this compound? Okay. Well, when a compound C4H8, C4H10O, okay. This C4H10O reacts with the 20% of orthophosphoric acid. Okay. Well, upon that, only alcohols can form alkenes, double bond compounds to give in presence of orthophosphoric acid. So in this question, in this concept, we should consider alcohol. So the alcohol would be CH3OH. Okay, both the number of carbons and the hydrogen and oxygen are equal with that of, we could proceed by treating it with orthophosphoric acid, H3PO4 at 383 Kelvin. Okay, and by that we could prepare the methylene, okay, alkene group. So this is the alkene group, double bond CH2. Okay, this is the alkene that is formed by the treatment of orthophosphoric acid along with water, right? Yes, this is the reaction. And write the IUPAC naming of the compound B, which is propene, actually 2-methyl propene. There are 3 carbons propene at and a methyl group at second carbon. So it is a 2-methyl propene. Moving on to our next question. Which of the following does not represent the property stated against it? Yes, there are 4 properties that have been stated. Cobalt, iron and manganese in their ionic state. Well, we could not completely determine that actually. So we could remove that option. So we could remove option A. Titanium, vanadium and manganese in number of their oxidation state. Well, both of them have different kinds of oxidation state, so that is also wrong. And we will discuss about the paramagnetic behavior of these 3 compounds. Well, chromium 2+. What is the oxidation number, electronic configuration of chromium? It's actually 3d5 4s1. Yes, 4s1 3d5. 4s1 3d5. Upon which removal of 2 electrons give 4s0 3d4. Okay. There are 4 unpaired electrons and it is paramagnetic. Moving on to the next one, Mn plus 2, Mn plus 2, which has 4s0, 3d5, right? Yes, 3d5, which has 5 electrons, unpaired electrons. So this is also paramagnetic. Chromium is paramagnetic, manganese is paramagnetic, and lastly Fe2 plus. Okay, Fe2 plus, which has 4s0, 3d6, right? Which has how much? 4 unpaired electrons. Therefore, everything in that series are paramagnetic. So that we could say Cr6 plus, Mn2 plus, Fe2 plus are paramagnetic in behavior, and the option C is the correct answer for this question. And let us check there is no point in checking the last option, but we can check that. Density. Well, actually density can be determined by the electronic configuration, but not in the correct order. Okay, so we could exclude that. Moving on to our next question. Yes, the correct order of the boiling point in the following compounds. Yes, boiling point. How could we explain the boiling point in such compounds? Well, a boiling point is a certain temperature at which we could break the bonds in the compound. So far we could say that H2O contains hydrogen bonding. So it is much higher temperature needed to break such bonds. So we could say that H2O has the highest boiling point. Moving on to that HF and NH3. Well, regarding HF, fluorine is a quite electronegative element, and the bond between an electronegative atom and a electropositive atom is so much stronger than that of the NH3, which has weak bond containing a lone pair. So we could say that ammonia has the least boiling point, HF much higher than that of ammonia, and the highest boiling point with the water. Okay, so this is the correct option B. 44. Question number 44 has option number B. Am I right for this? Yes. Moving on to the next question. Which of the following property is true for the given sequence? Well, these are nitrogen family groups, which nitrogen, phosphorus, arsenic, terbium, and bismuth. Okay, so here we could say that the reduction property and bond angle are not much needed here. Bond angle depends upon the lone pair present in everything. So the presence of lone pair in ammonia tends to decrease the bond angle, so cannot explain the bond angle, not even the acidic character. Okay, so the correct option would be thermal stability. The thermal stability of every elements in the periodic table decreases down the group. So the correct option would be B, which has nitrogen has the highest thermal stability. Moving on with the phosphorus trihydride, arsenic trihydride, terbium trihydride, and bismuth trihydride. Okay, correct option for the 43rd question would be option number B. Our next question is, which one of the following does not represent Arrhenius equation? Okay, log K is equal to log A. How could we explain Arrhenius equation actually? Well, log K is equal to log A e raised to minus Ea by RT. With that, we could say that option D is the correct answer for this question. Okay, option D. 1 second. The remaining one are just absurd answers. So the correct option would be option number D. Moving on to the next question. Yes, a mixture of a phenol, aniline shows a negative deviation from Rolle's law. Okay, a mixture of phenol and aniline shows a negative deviation of Rolle's law. This is due to the formation of what? A polar covalent bonds, non-polar covalent bonds, intermolecular hydrogen bond, or intramolecular hydrogen bonding. It's actually because of the intramolecular hydrogen bond formed between the phenol molecules. Okay, phenol molecules tends to form a hydrogen bonding between same molecule to get a much higher rate. So the AA interactions are much higher than the AB interactions, so that it gives a negative deviation from the Rolle's law. So the correct option for this question would be option number C, intermolecular hydrogen bonding. Okay. Our next question is 2-methyl propane can be prepared by Wood's reaction. The haloalkenes taken along with the metallic sodium and dry ether. Okay, this is our question. 2-methyl propane. Okay, what do we mean by 2-methyl propane? CH3, CH3. Okay, with 2-methyl propane. Okay, this is our 2-methyl propane. We have to prepare this through a Wood's reaction method. Okay, what is a Wood's reaction method? When alkyl chloride when treated with sodium along with dry ether, we get alkenes. That is Wood's reaction. So far we have to determine whether to prepare. Okay, we could prepare this by treating with a methyl chloride. Okay, a methyl chloride and 2-chloropropane. Okay, 2-chloropropane. Yes. Isn't it? So that we get a correct option for this one. Along with the dry ether and sodium. Okay. We get byproduct of sodium chloride. So the correct option would be chloromethane and 2-chloropropane. Option number A. Okay. Option number A. Okay. This is the Wood's reaction between 2-chloropropane and methyl chloromethane. Okay. Moving on to our next question. In the analysis of group 3 basic radicals of salts, the purpose of adding ammonia chloride to NH4OH. We have discussed that we might be doing, we have done that lab exams and all, and the salt analysis method we are using that ammonium chloride salt to determine the group 3 basic radicals. Okay, what is the use of this one? It's actually we have to find out that to increase the concentration of OH minus ions, to precipitate the radicals of group 4 and 5, to suppress the dissociation of NH4OH, to introduce chlorine ions. What would be the main reason for this? Actually, have you ever heard about the concept of common ion effect? Well, common ion effect is nothing but certain salts are introduced into the solution which contain same ions than that of the solute molecules in the solution to suppress the concentration of that ions in similar concentration. Okay, so such effect is called common ion effect. Same way we have used to introduce NH4Cl to suppress the concentration of NH4 plus ion. So the correct option for this reaction would be to suppress the dissociation of NH4OH. Yes, common ion effect, where NH4Cl which gives NH4 plus Cl minus. This NH4 plus is then treated with is used to suppress the action of NH4OH, right? NH4 plus and OH minus. Okay. So far this is the right answer, common ion effect. We have earlier studied in the laboratory exams and teacher might have explained that to you in person, that we are using ammonium chloride just to the purpose of common ion effect to eliminate the common ions that are present in the solution. Okay. So question number, this is completed. Option number C, to suppress the dissociation of NH4OH. Okay. Moving on to our next question. In the following scheme of the reaction, okay, it's quite a bit different one. Okay. In the following scheme of the reaction, we have ethyl chloride. Okay, we do have an ethyl chloride with when treated with X, Y, and Z, three different types of reactions, three different types, yes, three different types of reagents, which gives fluoroethane, ethene, and butane, right? Yes. So what would be this? X, Y, and Z are quantitatively. What could we explain with this? Well, when a methyl chloride or alkyl chloride when treated with mercury fluoride, we get a fluoroalkyl group. Okay, so it might be Hg2F2. Okay, we could say that it's Hg2F2, right? Yes. When an alkyl chloride is treated with alcoholic KOH reduction, alcoholic KOH, we get ethene, double bond structure. So the second compound X is Hg2F2, okay, and Y is done through reduction, okay, it is done through reduction, and Z is nothing but sodium in dry ether. Simple Woods reaction, yes, sodium in dry ether, okay, reduction which is actually alcoholic KOH, right? KOH. Z is nothing but Woods reaction. Okay. You have to find out. We have to find out whether the reagents are important in such reactions. Okay. Then only we could answer these questions. We have to find out what are the reactions, what are the reagents used here, and what are the catalysts used here. We have to find out the byproducts and also the main products in the reaction, so that we could answer such questions. We will move on to our next question. The female sex hormone which is responsible for the development of secondary female characteristics and participate in the control of menstrual cycle is what? What could we explain? We do know that testosterone is not a female sex hormone, it's a male sex hormone. So not testosterone, not insulin. Insulin is a hormone produced by pancreas. No such reproductive organs are present. Thyroxine is a hormone produced by the thyroid gland for the for something for deficiency. Okay, and the last one, odd one out, is estradiol. So that is the correct answer here. Estradiol is the correct answer, which is the female hormone that produces the secondary sex characters in females at reaching the age of puberty. Okay, we will move on to the next one. Right. The biodegradable polymer obtained by the polymerization of glycine and aminocaprioc. Okay, that kind of a polymer. We have changed suddenly from biomolecules to polymer sections. Well, we'll look at that. What are the biodegradable polymer? Nylon and nylon 66 are not a biodegradable. Okay, we could rule out that one. Nylon 6 is not a biodegradable. It's actually nylon 2, nylon 6 polymer, right? We have studied in the polymer section that nylon 2, nylon 6 is a biodegradable polymer obtained by the polymerization of glycine and aminocapriox. So the correct option for this question would be option C, nylon 2, nylon 6, right? For our next question, the complex compounds, okay, the complex compound, what are the pentamine, sulfate, cobalt 2 bromide and pentamine bromo cobalt 1 sulfate. Okay, these two, I don't think I might get that actually. It's actually what kind of isomers, coordination isomers or geometrical isomers or optical isomers or ionization isomers. Well, it's easy to find out that actually these are all ionization isomers, because on ionizing this first we get bromine as ion. Okay, we do know that, and by this we get SO4 2 minus as the ion. Okay, we do know that both are same, both of them have the same chemical formula but gives out different ions on ionization. So that these are called ionization isomers, and the question is both of them are ionization isomers. Okay, so the correct option would be option D, right? Yes, option D is the correct. Our next question, But1 wine on reaction with dilute H2SO4 in presence of mercury 2 plus ions in 313 Kelvin gives. Okay, this is our question. Well, we might write the question. Okay, But19. Well, we will write the equation. Sorry, chemical formula of But19, CH2, CH. This is methylpropyl. But. Okay. One second. I have written it wrong actually. It's actually propane. We'll write CH triple bond CH. Okay. Am I right for this one? Yes. It's a buta-19 when treated with Hg plus and H2SO4. Okay. What do you mean by this? This is an acidic hydrolysis or hydration reaction, right? What do we get here? We get OH minus ion. Yes, according to the sorry, there is no H in here, right? Yes, only one a carbon is present in here. So C triple bond CH. When this is present here, we get OH minus ion. The negative part of the adenum goes to the lesser number of hydrogen. Yes, that's the same. We get CH2, COH, double bond CH. Okay, this is our reaction, and upon this, actually there is another effect called tautomerization. When a OH group is present inside of a double bond, okay, the parent carbon atom has a double bond in structure. They might interchange equally to form a ketone. Okay, this might equally tautomerizes to form CH3, CH2, C double bond O, CH3. Okay, this is the reaction, right? We have found out that one. So the product would be, which is 1, 2, 3, which is double bond and 3. The correct option would be option number A. Am I right for this question? Yes, option number A is the correct answer. We'll move on to our next question. It was such an easy one. We have to find out it is a reduction of a triple bond in presence of mercury sulfate and water. Actually, it's an acidic hydrolysis. Okay, to get a alcohol, which then tautomerizes to form a ketone. Yes, we have studied that in the aldehydes, ketones, and carboxylic acid chapter. Let's move on. Let's leave it at that. Our next question is: how many coulombs are required to oxidize 0.1 mole of H2O to oxygen? Well, we have to oxidize H2O, which means oxidation of H2 gives H2 plus half wood. Okay, this is our reaction. Okay, balanced chemical reaction right down here. How many coulombs are required to oxidize 0.1? When 1 mole of H2O gives 2 Faradays, right? 96500, okay, into 2. You know Faraday's law, yes. And 0.1 mole of this substitute gives 96500 into 2 by into 0.1. Okay, you have to find out into 0.1 divided by 1. Is it right? Yes. The number of oxygen atoms is equal to 1.93 into 10 raised to 4 coulomb, unit of Faraday. Our next question is the value of A in the equation delta Onsager equation. Okay, Onsager equation is same for the pair. That's what we are saying. We have discussed this earlier. Delta M is equal to, these are all repeated questions. Okay, we have delta M is equal to lambda M is equal to lambda naught M minus A root C. Okay, this is our question. Okay, for this we have to find out the constant is the same, value of A is same. We have earlier discussed about that the Onsager equation depends upon temperature, solvent, dielectric constant, and the number of ions present here. We have never specified any solvents, or we do not explain any temperature difference, and the only thing that we know is the number of ions here. So we could say that the value of A in this reaction is depending upon the number of ions. So the equal number of ions has only with NaCl and KBr, because both of them produce 2 ions per each. MgCl2 produces 3 ions, whereas NaCl produces 2 ions. Okay, 1 and 2. This is correct. This is the correct one. CaCl2 produces 3 actually. 3 and this produces 2. NaCl produces 2 and CaCl2 produces 3. Okay, so the correct option for this question would be NaCl and potassium bromide, which produces equal amount of ions, and so far the A value, constant value for both the reaction is same.